Astronomers have just peered into the atmosphere of one of the most extreme exoplanets ever discovered. Although it's absolutely not habitable, at least as we understand it, the exoplanet Wasp 189b is the first in which scientists have been able to probe distinct atmospheric layers, each with their own chemical compositions and characteristics. In the past, astronomers often assumed that the atmospheres of exoplanets exist as a uniform layer and try to understand it as such, says astronomer Hoeijmakers of Lund University in Sweden. But our results demonstrate that even the atmospheres of intensely irradiated giant gas planets have complex three-dimensional structures. Wasp 189b is a member of one of the most intriguing subsets of exoplanets, hot Jupiters. These extreme worlds are gas giants, like Jupiter, but on insanely close orbits with their host stars, whizzing around in less than 10 days. Naturally, their temperatures are therefore scorching. In addition, we don't know why they are like that. According to our current models of planetary formation, a gas giant can't form that close to its star, because the gravity, radiation, and intense stellar winds ought to keep the gas from clumping together. Yet, of the nearly 5,000 exoplanets confirmed to date, over 300 could be hot Jupiters. Learning more about these hell worlds should thus reveal more about the dynamics of planetary systems. Wasp 189b, about 322 light-years away, is among the most extreme, although it's not quite the most. It's about 1.6 times the size of Jupiter, and orbits its star on a breakneck 2.7-day period. That star is young and hot, which means surface temperatures of Wasp 189b reach up to 3,200 degrees Celsius, 5,792 degrees Fahrenheit, on its day side, making the planet hotter than some stars. It's also one of the brightest transiting exoplanets known, that is, it passes between us and its star. In turn, that makes it very attractive for atmospheric studies. We measured the light coming from the planet's host star and passing through the planet's atmosphere, explains astronomer Bibiana Prinath of Lund University, who led the research. The gases in its atmosphere absorb some of the starlight, similar to ozone absorbing some of the sunlight in Earth's atmosphere, and thereby leave their characteristic fingerprint. With the help of HARPS, high-accuracy radial velocity planet searcher aboard ESO's La Silla Observatory, we were able to identify the corresponding substances. As is often seen in hot Jupiters, those gases included vapors of heavy metals. Wasp 189b's atmosphere is drifting with clouds of gaseous iron, titanium, chromium, magnesium, vanadium, and manganese. Interestingly, the researchers also found traces of titanium oxide, which has never been conclusively detected in an exoplanetary atmosphere before, the researchers said. Titanium oxide is found rarely in nature on Earth, but on Wasp 189b, its presence could be helping shape the atmosphere. Titanium oxide absorbs shortwave radiation, such as ultraviolet radiation, says astrophysicist Kevin Heng of the University of Bern. Its detection could therefore indicate a layer in the atmosphere of Wasp 189b that interacts with the stellar irradiation similarly to how the ozone layer does on Earth. There was another big clue that the team was observing layers in the exoplanet's atmosphere too. Elements in space are detected spectrally, that is, we split the light detected by our instruments into the full spectrum and look for brighter or darker lines. These indicate that something is either amplifying or absorbing those wavelengths, what we call emission or absorption lines. Absorption lines can then be traced to specific elements that we know absorb those wavelengths. But the absorption lines from Wasp 189b were not quite where the researchers expected them to be. We believe that strong winds and other processes could generate these alterations, Prinath said. And because the fingerprints of different gases were altered in different ways, we think that this indicates that they exist in different layers, similarly to how the fingerprints of water vapor and ozone on Earth would appear differently altered from a distance, because they mostly occur in different atmospheric layers. Obviously, we won't be traveling to Wasp 189b anytime soon. Even if we were, life as we know it would be megacaput before we even landed. However, the research still has relevance to the search for life. It represents a new milestone in probing exoplanetary atmospheres, which is where we are most likely to spot the signs of alien life.